Today, I'll write a small program using the C programming language on Linux, and I'm actually going to do it properly and handle most of the errors. What will the program do? Well, it's just going to copy a file. That's it. Now, of course, I'm using Visual Studio Code with stock settings, no mouse, and no AI. If you want to follow along, I'll leave the extensions I use in the comments below. Alright, close that. Let's make a new file and let's save it as main.c. Let's start the main function. Sorry, there we go. So this program will copy a file. We need a source file and a destination file. We're going to get that from the command line arg, so let's actually accept those. The first argument is always the path to our executable. We don't care about that. The remaining arguments are user-provided arguments. We do care about those. We want a source path and a destination path. That's 2 user-provided arguments plus executable path, which is 3 arguments. If the number of arguments is not 3, we want to report an error to the user. For that, I want to use fprintf. Let's take a look at the man page for that. We see it comes from stdio.h. Include stdio.h. fprintf to std_err. Please provide a source and a destination file. And now we want to exit with failure. Let's look at man exit for that. And that's from stdlib.h. Exit with exit failure. Now, we want to open the files provided to us by the user. For that, we will use the open system call. We see that it's a system call by the category 2 of man pages. That's from scntl.h. Let's actually include that. Let's take a sec to study the man page here. So the first argument is the path name. That's pretty obvious. Let's look at what flags are. So the first file, the source file, I want to open just for reading. That's fine. Second file, I want to actually create and then paste into it. So let's actually search for create. There we go. O created the flag for creating. And we actually need to additionally specify in this case what sort of permissions we want the file to be created with via these smode flags. All right, so let's actually do that. So int file descriptor. Oh, I didn't say that. So let's go to return. So on success, these return a file descriptor, which is a non-negative integer, and on error, they return -1. So file descriptor source is going to be opening argv1 only for reading. So if this fails, so if the file descriptor is -1, we want to tell that to the user. So once again, looking at the man page, the error is stored in errno. Let's look at the man page for errno. That's errno.h. Let's include that. So one particular error case I want to handle especially here is the errno eno_end, which means that the file the user provided doesn't exist. And let's tell him that. The file percentage does not exist. The file is argv1. In every other case, I want to say could not open the file for editing, for reading, sorry, not editing. And in both cases, I want to exit with exit failure. Let's do the same for the destination. Open argv2. So we only want to write. We want to create that additionally. And we want to make sure that the creation doesn't overwrite something, because this is a copy, not a replacement. So we need to specify which permissions the created file will have. So as I read user, so I want the user to be able to read, and as I write user, I want the user to be able to write to the file. Once again, we need to check if this call failed. Fd des equal -1. One specific case I want to handle again is the case that the file exists sorry, we specifically asked the open system call to not overwrite files. So it's going to tell us if the file already exists by setting error node to exists. So let's fprintf to std error the file %f already exists, and the file is argv2. And in all other cases, I will write to std error cannot open file %s for reading. I just noticed a mistake I'm making. Maybe you have too. I forgot to add a new line in a couple of places. Can use VSCode's search feature here. Using Shift Enter to go backward, Escape twice to stop the search. All right. Now, we can't just exit. I mean, technically we can, but it's kind of unclean, and I want to show proper error handling techniques. The reason we can't just bail here is because we have an open file descriptor, which is the source file descriptor, which we would be very nice to close. So for that, I'm going to use a paradigm called goToError. I'm going to make a label error, and at this label, we're going to close the file descriptors if they're valid. Valid meaning greater than or equal to 0. Now for close, we need to actually look at the man page. That comes from unistd.h. There we go. Close fd source. And if the file descriptor destination is greater than or equal to 0, I'm going to close fd destination. Space too many here. There we go. So here we're going to say goToError, and in more than just one place. So if an error is encountered, the program will jump control here. Now, mind you, this is the main function. So at the end of the main function, we need to return a status. And the way I'm going to do this is actually, I'm going to make a variable status. Let's say exit status equals exit failure. And we're going to return the exit status. So by default, it's going to be exit failure. But if the program makes it to this point in the happy path, we're going to change that variable to be exit success. Excellent. So now we've got the two open file descriptors we need to actually copy. For that, I'm going to make a specific function to copy files. So we'll take the source file description and the destination file descriptor. All right, so how do we copy? So first, we need to know how much we're going to copy. For that, we will use the fstat system call. Comes from sysstat.h. It's already included. We see it gets a structure pointer to a structure stat and a file descriptor. So let's make a struct stat file stats, and let's open. Not open. We want to fstat file descriptor source into the address of file stats. Taking a look at the man page once again, let's look at return value. On success error is returned, on error -1 is returned. So we need to check this. So if this returns -1, an error has occurred. So I'd like to report an error out of this function without actually handling it locally. The way to do that in C is by returning something. And I'll be a little bit clean here. I'll use a specific enum. So the possible statuses for copy will be success, which I'll set to be 0. It would be that we can't get the length of the file, so unknown len, and that we can't copy. So in this case, we're going to return unknown. Oh, I forgot to change the signature. We are actually returning an enum copy status. All right. The way I'm going to copy is using the copy file range system call. Let's study this for a sec. So first, we need a couple of defines and an include to get access to it. So we need to define GNU source, and we need to define file offset bits. Let's do that. Define GNU source and define file offset bits be 64. So the parameters for copy file range are an input file descriptor, an offset for the input, an output file descriptor, an offset for the output, a desired length, and some flags. Let's quickly demystify flags. It's provided to allow for future extensions and currently just must be set to 0. The rest of the arguments are quite obvious. Let's take a look at return. Upon successful completion, copy file range returns the number of bytes copied between files. This could be less than the amount originally requested, so the kernel is allowed to disrespect our wishes. In order to take care of this, we need to actually loop. So if the copy is not complete, if the copy does not copy everything we want, we need to copy again. Oops, my bad, that's a typo. Let's implement that using a loop. So I'm going to make a variable for the file size. That's going to be file stats.st size. I'm going to make a variable to track how much we have copied. Let's initialize the variable to 0. Always safer to initialize variables. We also need an offset. I will initialize that to 0 too. Then I'll use a do while loop. So if you have noticed in the man page, on error, copy file range returns a negative number. So we're going to say that the copy count is equal to copy file range. The input file descriptor is the file descriptor source. The offset is just the address of offset. The out file descriptor is file descriptor destination. Same offset. The length is the file size. And the flags we've seen have to be 0. So if copy file range fails, it returns something less than 0. So we're going to loop while copy count is greater than or equal to 0. And then we're also going to loop while there is something actually remaining in the file. Because once we've copied something, we're going to subtract that from file size, minus equals copy count. And we're going to add that to the offset, because that's the offset we want to continue copying from. There we go. So if the reason we broke out of this loop is because copy count is less than 0, then an error while copying has happened. Oh, I forgot the semicolon at the end. So that's what we are going to return. Otherwise, we're going to return success. Let's go back to the main function. Let's actually call this. So enum copy status equals copy file from file descriptor source to file descriptor destination. If the status is error copy, let's tell that to the user. Oops, bad. So the error, the format is error while copying dot new line semicolon go to error. And if the status is unknown length, fprint f stood error couldn't get size of source file. And let's not forget a new line. There we go, go to error. And believe it or not, we are done. So let's, oops, I keep typoing this, my bad. Let's actually use GCC to compile this, -o main. Let's echo hello world into a test file, hello.txt. And let's do main hello.txt into out.txt. Let's cat out.txt. And we see our program has worked nicely. Thanks for watching. I'll see you in the next one.